Hello Year 12, this is me doing the mini test that you did a little while ago. I'm just going to work through it live. I've not looked ahead. I've written, you can see I've marked the answers just to check I get it right as I go through, but this is me working it through. So the first one, just asking you to work out the formula mass of something, or which one has the formula mass of 56. If you work through them, the only one that has a formula mass of 56 is potassium hydroxide. I've got a periodic table here that you can't see. Potassium is 39. Oxygen's got a mass of 16 and hydrogen's got a mass of 1, and that comes to 56 grams per mole. So that one's nice and straightforward. So that's the first one. Second one is, what's the maximum mass in grams of magnesium oxide that can be obtained? Well, you first of all need to write a balanced equation for that one. So magnesium plus oxygen goes to magnesium oxide. Magnesium oxide's got a formula MgO because each of the 2 plus ions. So to balance it, we need a 2 there and a 2 there. And we've got 2.4 grams of magnesium. That's the mass of magnesium. We've got ratio of 2 to 1 to 2. MR is 24 of magnesium, and so the number of moles is 2.4 over 24 is 0.1. Now you won't get a calculator for your paper 1. These are paper 1 questions, so you need to be able to do simple sums like that, which means we also get 0.1 moles of magnesium oxide because they react in a 2 to 2 or 1 to 1 ratio if you like. The formula mass of magnesium oxide is 24, add 16, which is 40, and so the answer must be 0.1 times 4t, which is 4 grams. So there's your answer there. Like so, if you set it out as the grid method, as long as you get a balanced equation, it should have been pretty straightforward. The next question, you have to work out the coefficient for oxygen when you burn 1 mole of pentane. So you're quite often asked in chemistry in chemistry papers to balance equations of for the reaction of the complete combustion of hydrocarbons. Trick is just to look at the number of carbons. That must equal the number of moles of carbon dioxide. So there's 5 carbons here, there must be 5 carbon dioxides. There's 12 hydrogens, there must be 6 waters, which means if you tot up the oxygens, 10 add 6, 10, which is 5 times 2, add 6, which is 16 oxygens, so you must be an 8 there, and that's the answer. For this one, again, you've got to balance the equation to start with and add together the coefficients. Okay, so and make sure you've got the smallest possible whole numbers. So just start off with the carbons, just like we did in the last one. That's 2, so that must be 2. There's 2 there and 2 there. We add together the oxygens. 1, 2, 3, 4, 5. So that at the moment must be 2.5. Okay, but it does say you've got to balance it with whole numbers. So if you balance it with whole numbers, it will be 2 to 5 to 4 to 2, 7, 8, 9, 10, 11, 12, 13 is the answer. Okay, none of the others work. So just to show you, that's if we were doing it very simply, and we've had to make it whole numbers, so 2 to 5 to 4 to 2. Question 5. This is a little bit tricky, this question, I think, and a few people got caught out on this one. So we've got equal masses of those metals that added to HCl. Now to start with, you should know that silver's unreactive, so it ain't that one. So it had to be one of the others. You've got to think about the 2 things really. You've got to think about the mass for all of them being the same. You've also got to think about the balanced equation, I suspect. So let's work this through. So sodium would be Na plus HCl goes to NaCl plus H2. If you balance that, as a reaction you would know from GCSE. 2 there, 2 there, and 2 there. So clearly the sodium to hydrogen ratio there is 2 to 1, and that will sure be important. The magnesium and calcium balanced equations are going to look exactly the same as each other. I've done a few of these sorts of things in the past, so I can see straight away. I know that magnesium chloride is MgCl2, so I knew there'd be two acids there producing 1 mole of hydrogen, and the calcium is also group 2, so it's going to be the same balanced equation. There we go, so we've got that reaction going on. Now, let's think about this to start with. So we've got sodium, which has got a formula mass of 23. Magnesium's got a formula mass of 24. And calcium has got a formula mass of 40. The first thing we've got to look at is we've got to look at the molar ratios. Okay, so every 2 moles of sodium would generate 1 mole of hydrogen, or if you like, every 1 mole of sodium would generate only half a mole of hydrogen. So it ain't going to be that one, because it produces half as much hydrogen per mole of sodium. So it had to be either calcium or magnesium. Now, the one of these that produces the most moles of hydrogen is the one that there's most moles of, because they're both reacting at 1-to-1 ratio, if you like. Or 1 mole of that produces 1 mole of that, and 1 mole of that produces 1 mole of that. So magnesium has got a smaller atomic mass than calcium, so 1 gram of it, let's say, would be more moles, because 1 divided by 24 is a bigger number than 1 divided by 40. So this must be the highest number of moles of of metal, which must produce therefore the highest number of moles of hydrogen. So that would be the answer. This one's really very straightforward. This one, you simply have to add together 24 for the magnesium, 32 for the sulfur, 4 lots of 16 for the oxygens there, plus 7 lots of 18. Now, I'm not going to spend time totting this up. I know that's 246. Okay, that's all you have to do there. 7 lots of 18 is 7 lots of water. Each water is 1 plus 1 plus 16. How many molecules in a drop of ethanol with a mass of 2.3 times 10 to the minus 3? Ethanol's formula mass is 12 add 12 add 5. Whoops. Yes, 12 add 12 for the 2 carbons, add 5, add 16 for oxygen, add 1 for the other hydrogen. 24, 46, that comes to 46. Okay, so moles equals mass over mR. 2.3 times 10 to the minus 3 grams divided by the formula mass is 46. Now, people struggle with these sorts of sums, and I understand that. You need to be able to do sums like this in your head, or at least on paper, if you're going to solve questions like this in your exams. Hopefully you can see that 23 is half of 46. So 2.3 is a tenth of that, isn't it? 2.3 divided by 46 is a tenth of a half, so 0.05. So if you like, it's 0.05 times 10 to the minus 3 moles. Okay. The reason I've got that, by the way, is moles equals mass over mR. There's the mass, there's the mR, and that must be the number of moles. So to work out the number of molecules, you times the number of moles by Avogadro's number. So it's L, if you like, which is Avogadro's number, times by 0.05 times 10 to the minus 3. And they've just given it as 6 times 10 to the 23 here. So let's work that through. I think it's simpler if we work it out as L times, if we write this in proper standard form, it's a bit easier, I think. So 5 times 10 to the minus 5. So L is 6.0 times 10 to the 23 times 5 times 10 to the minus 5. So 6 times 5 is 30. And then we can just add together the indices from here, 23 and minus 5. So it's 30 times 10 to the 18 which is equal to 3 times 10 to the 19, which thankfully is the right answer. Okay. Which sample has the greatest mass? Mass equals mR times moles. So all we've got to do is work that out. So the mR of sulfur dioxide is 32. Add 2 lots of 16, which is 32, is equal to 64. So for the first one, it's 64 times 1. So that's the mass there, 64 grams. mR of N2O. So I'll just write SO2 here. N2O here is 28 for 2 lots of 14. Add 16, which is 44. 2 times 44 is equal to 88. Argon is simply 40. So 2 times 40, which is 80. And 4 lots of ammonia. Ammonia is NH3, a chemical that's worth learning the name of if you don't know it. 14, add 1, add 1, add 1, which is 17. 4 lots of 17. 17 times 2 is 34. So 17 times 4 is 68. And therefore the answer is B. That should be pretty straightforward, that sort of question, folks. Question 9. What mass in grams of hydrogen is forming 3 moles of aluminium with excess hydrochloric acid? Now, we haven't done limiting reagents yet. We'll do that in time. But the fact that it's excess hydrochloric acid means we can kind of ignore it in this question. So we've got 3 moles of aluminium. It's going to react with hydrochloric acid. And all we've got to do is just follow the process. 2 to 6 to 2 to 3. There's the ratio. Mass, mR, number of moles. Only things we need to worry about, because of where the question's written, is the aluminium and the hydrogen. Mass, we don't even know the mass. We just know it's 3 moles of aluminium. So there must be, it's a 2 to 3 ratio. So to get from 2 to 3 times 1.5, so it must be 4.5 moles of hydrogen. And then the mR of hydrogen is 2. 1 add 1, of course, is 2. And so the mass is moles times mR, so it's 9 grams, and that's the answer. The total number of hydrogen atoms in benzamide, well, we've got 1 mole, and in benzamide there's 1, 2, 3, 4, 5, 6, 7. So in 1 molecule there's 7 hydrogens, and in 1 mole of benzamide there's Avogadro's number, which is 6 times 10 to the 23 molecules. So 7 atoms times 6 times 10 to the 23 is 4.2 times 10 to the 24, or if you like 42 times 10 to the 23, and then if you just turn that into true standard form you get that. Knowing your times tables, by the way, massively helps you here. Sum of the coefficients. All you've got to do for this one is balance the equation. Got 2 nitrogens here, so we must need 2 there. Got 4 hydrogens here, so we must need 2 waters. 1, 2, 3, 4 oxygens, 5, 6 oxygens. We must have 3 there. I think some of you got stumped with this one because you forgot that that would be 1. 1, 2, 3, 4, 5, 6, 7, 8. Chloroethene, ethene, reacts with oxygen according to this reaction. So we've got a 2 to 5 to 4 to 2 to 2 ratio. I'm just writing underneath to save a little bit of time. We've got 10 moles. Okay, this is a relatively hard question because it's a limiting reaction question. We haven't done this. So if you got this wrong, don't worry. Well done if you got it right. We've got 10 moles of this stuff. So let's put N. 10 moles. There's the ratio. And you've got 10 moles of oxygen. And they're mixed together. Now, they react in a 2 to 5 ratio. So if you had 2 moles of this, they would react with 5 moles of this, if available. if you've got 10 moles of it, it would need 2.5 times as much of that. You'd need 25 moles of oxygen. You haven't got enough of that, so this stuff must be in excess. Now, don't worry if that means nothing to you. You've not done that before. We will cover that in class soon. So this is in excess, and I'll teach you the way I get you to set that out. We'll put that in brackets. We'll just check that by looking the other way around. So oxygen, there's 10 moles. You can check that it's the limiting reactant, and by the way, we underline the one that's limiting. You can see that this stuff's in excess because you only would need 4 moles of this. You divide by 2.5, you'd only need 4 moles of the chloroethene if you had 10 moles of this. You've got way more of this than you need. So this, the limiting reactant, is the one that determines how many moles of water you would get. Okay. To go from there to there, you're dividing by 2.5, or if you prefer, divide by 5 times by 2. And so if you divide 10 by 2.5, you get 4, and happily that's the right answer. Question 13. Which of the compounds below contains the least number of ions? Right, this is one that stumped a few of you. Sodium hydroxide is made of sodium ions and hydroxide ions. Ammonium chloride is ammonium ions and chloride ions. Calcium chloride is calcium ions and 2 chloride ions. And there, for this one, there's, for aluminium oxide, there's 2 aluminium ions and 3 oxide ions. So 1 mole of this equal to 5. 2 moles of that is 2 times 3, which is 6 moles of ions, if you like. This one, there's 2 times 1, and this one is 2 times 2, which is 4. The reason it's 2 times 2 is the number of moles times the number of ions. Number of moles times the number of ions. So the one with the fewest is this one, which is the right answer. There we go. Hope that's useful. Let me know if there's anything you want further help with. Cheers!